Okay, so today we're going to start chapter 8, which is matrices and determinants. We're going to go back to systems of equations, which we just did in chapter 7, and we're just going to solve them a different way, and we're going to put them into matrices to solve. Okay, so first of all, you're going to find out what a matrix is. You're going to perform elementary row operations on matrices, and then we're going to use matrices in Gaussian elimination, and then we're going to do Gauss-Jordan elimination, which these should look familiar to you because we've already talked about these, yes? So we're going to, and you're going to still just do back substitution and all that stuff. So let's get started. This is a matrice. A matrice is an array of numbers that are put into rows and columns. It kind of looks like, to me, it reminds me of Excel. Yes? Everyone's worked with Excel? So you're going to have rows, you're going to have columns, and you're going to, so when I look at these, I'm going to have, these are my rows, these are my columns. Every element is going to be identified by its row number first, its column number second. So element 3, 2 means that it's in row 3, column 2. That's not hard. To name a matrix, we're going to always do it's always going to go rows by columns. So if I have a matrix that's written like this, and I'm going to say that that's a 2 by 3 matrix because I have 2 rows, 3 columns. If I have one that's written like this is going to be a 2 by 3 because they have, no, a 3 by 2 because I have 3 rows and 2 columns. See the difference? A square matrix means that the number of rows equals the number of columns. So if I have a 2 by 2, 3 by 3, and sometimes we get up to a 4 by 4, those are all square matrices. If I have a square matrix, I'm going to have what's called a main diagonal. So if I have a, let's do a 3 by 3. There's my square matrix. It's a 3 by 3. If I have a square matrix, I have a main diagonal. The main diagonal goes in one direction, from upper left to bottom right. That would be my main diagonal. Haven't lost anyone yet, have I? So if I ask you to give me the dimensions of these matrices, you should be able to do this. Kaylee, what's the first one? 1 by 1. Then the next one, Connor. How many rows do I have? 3. How many columns do I have? 1, so it's a 3 by 1. Brooke, the next one. 3 by 3. And then finally the last one, Caitlin. 2 by 4. Everyone good? Okay, up until this point, nothing has been hard, right? Okay, now what I'm going to do is I said we're going to solve systems using the matrices. So there's 2 types of matrices that we write when we talk about some systems. One's called the augmented matrix, which takes the x, the y, the z, and the answers. So every coefficient of x is in the first column. Every coefficient of y is in the second column. Every coefficient of z is in the third column. My answers are in the fourth column if I have a 3 unknown system. This would be equation 1. This second row would be equation 2, and the last one would be equation 3. Does that make sense? In an augmented matrix, you have both the coefficients and the answers. In a coefficient matrix, it's still x, y, and z, equation 1, equation 2, and equation 3, but now you don't have the answers. You just have the coefficients. And depending on how we're using matrices to solve the systems, it depends on whether we use the augmented matrix or the coefficient matrix. Today, we're just going to use the augmented. That's all we're going to use today. Okay? So when I go, the first thing I have to do is I have to learn how to write an augmented matrix into, a system of equations into an augmented matrix. Francesca, would you like to try?
So it would be
Yep. Okay, you have to have the dots to separate the coefficients from the answers. If I were missing an X or a Y or Z, I would put in a 0 to fill in that space. That's easy, right? So I'm going to do what's called elementary row operation, and I'm going to learn how to change two rows, multiply a row by non-constant, and then multiply. And we're going to do that to manipulate our rows so that we can eliminate different elements of our matrix. So, and this is stolen from the book. So in this one, what I've done is I've taken row 1 and I've moved it to row 2 spot. And I've taken row 2 and I've moved it to row 1. As long as I move the entire row, I can interchange the rows. Okay? In the second one, I took row 1 and I multiplied it by 1/2 and I rewrote it here. Notice I multiplied everything by 1/2. And there's reasons why we do this. We'll get there in a second. C is a little bit more complicated because I did two things. I took -2 times the first row of the original matrix and added it to the third row. So what that person did is they took -2 times this row right here. So when they did that, they got -2, -4, +8, -6. Then they added it to the third row, 2, 1, 5, -2. And when they added them, they got 0, -3, 13, and -8. And that's what they put into row 3. It doesn't matter where you put it, but that's where they put it. That's not bad, right? So let's try and do some ourselves. So on the first one, I want you to interchange the first row and the third row of the matrix. Ryan, can you tell me what you got? Yep. Okay, in the second one, we're going to go back to the original matrix. So we're going to go back here, and we're going to multiply the second row by a -1/2. If I'm multiplying the second row by a -1/2, what's happening to row 1 and row 3? Anything? No, nothing. So Andrew, you ready? I'm multiplying the second row by -1/2. Oh, I'm up here, second row by -1/2. What's 3 times -1/2? Am I making a mistake? I don't think I am. I'm going to write it and you tell me if you understand what I'm doing. Okay. Keep on going. Mm-hmm. Yep. And then the third row would be? Yep. And then the last thing I want to do is I want to add -3 times the first row of the original matrix to the second row. So I want you to go all the way back up here. And I want you to take -3 times the first row. And I want you to add it to the second row. And why don't you put that in the second row? Doesn't matter where you put it, but we're going to put it in the second row. I'm going to put this so I can still see it. Yes. Okay, Rachel, what's your first row going to look like? 1, 3, 4, 0. That one is not changing, yes? So what did you get for the new second row? And what was the last one? I agree. Is everyone good with that? And then the last one, my last row would be what, Kyle?
1, 2,
Okay, that's not bad, right? Biggest mistakes is simple algebra or simple arithmetic mistakes. Okay, so this one we're going to solve the system. But before we solve this system, I want to explain to you what you're going to do. You're going to have two things that you're going to do. You're either going to do what's called row echelon form or reduced row echelon form. Row echelon form says that I have a matrix, and I'm just making up numbers. They're not on your paper, just randomly making up numbers. And what row echelon form says is that pretend that these are your answers, right? And if I eliminate the answers, I'm left with a coefficient. My coefficient should be a square matrix because I have 3 unknowns and 3 equations. That's how I can solve it. My main diagonal should be all ones, if that were my 3 by 3, ignoring my answers. And then everything below that main diagonal is going to be a 0. This is what's called row echelon form. Not to be confused with reduced row echelon form, which looks something like that. With reduced row echelon form, again, here's your answers that we're sort of like pretending that they're not there. And we're just looking at the coefficients. My main diagonal is still all ones, just like it was over here in row echelon form. But what's the biggest difference? Not only is everything below the line zeros, what's everything above that line? Zeros. This is called reduced row echelon form. The advantage of reduced row echelon form is if I were to convert it back to the x, the y, and the z, this would be 1x, 0y, 0z, so it would just be x is equal to 6, y would equal 7, and z would equal 13, and I would have my answers. That's row echelon, reduced row echelon form, right? If I went to this row echelon form, I would have x plus 3y plus 5z is equal to 6. Y plus 7 is equal to 8, and then z is equal, 7z, oopsie, and z is equal to 13. This gives me the opportunity to do the back substitution. That's row echelon form. We're going to start doing two like this, and then we'll try and get one of those done, okay? That's my objective. So let's, where'd it go? It's here. So here, the first thing I have to do is I have to put this as an augmented matrix. So, Zoe, what's the augmented matrix? Now, the object is to make, what we're trying to do is we're trying to make these all ones, and we're trying to make these all zeros. That's what we're trying to do. So the first thing I want is I want a 1 here. Do I already have that 1 there? Yes. If I did not have a 1 there, I would desperately hope that one of the other two had a 1 so I could interchange the rows and make that first one a 1. So I have a 1 there, so that's good. So now what I'm going to do is I want to make this and this a 0. I have to do this one first and then this one second. What am I so I'm going to do some type of multiplying and adding so that when I add two matrices together, this 2 is eliminated and becomes a 0. So what I'm going to do is I'm going to take -2 times row 1 and I'm going to add it to row 2. When I do that, I'm going to have -2, -6, -8, -14. And I got a 0 here, which makes me happy, yes? Now I want to do some other combination where I can make this 3 a 0. What would I have to do to make that 3 a 0? John?
Make that 3 a 0, you would take the first equation, like -3.
And then add it to the third, right? And see the nice little notation I'm doing? Are we all doing the nice little notation? Your math teacher loves it when you do that. So my first row, I'm leaving alone. My second row, I'm going to replace with this. And my third row, I'm replacing with this. Everyone good? Now see, when we were putting this in row echelons form, you see how the first column was a 1 followed by 2 zeros? See how right now in this problem I have a 1 followed by 2 zeros in my first column? So that first column is done. You good? Since the first column is done and I have these 2 zeros here, when I go to fix row 2 and row 3, I'm not going to want to use row 1 again, because if I use row 1 again, I'm going to mess up these zeros because of that 1. Does that make sense? So I'm done using row, especially if I'm just doing row echelon form. Once I have that first column done, I never touch row 1 again if I'm doing row echelon form. If I'm doing reduced row echelon form, I'm not quite done yet, but right now I'm going to say I'm done. All right. So now I'm going to, so I have this one here. I have this one here, so that makes me happy, yes? I need to make this one here a 0. How am I going to make that one there a 0? Kyle? Yeah, so I'm going to say -1 times row 2, and I'm going to add row 3. So I got this to be a 0, but I really want this one to be a 1, right? I want this to be a 1. Can I fix that so it's a 1? What would I do? Divide by -5. If I divide this whole thing by -5, I'm going to get 0, 0, 1, -2. And that's what I'm going to want to put in my last row. Oh, that's a... I have that main diagonal of 1s. Everything below it is zeros. I'm now in row echelon form. If I'm in row echelon form, I'm going to do back substitution. Aiden, before I can do back substitution, I want to put my X, my Y's, and my Z's back in. Can you help me do that? Yep. Yep. So now that I have this, this is exactly what we did last chapter, and that's the easy part, right? All I have to do is back substitute in. Good. Not terrible. Kind of fun. Huh? It takes so long. So when I look at this A, I want you to tell me whether it's in row echelon form or reduced row echelon form. Kevin. That is in row echelon form because I have the ones, have the zeros, but these numbers are different. Oh, Vincent, B. Is it in row echelon form or reduced row echelon form? It's in neither. This row of all zeros, guess what that does to your problem? No solutions. This row of all zeros, no solutions. This row of all zeros, no solutions. Looking at number E, Vincent, if I wanted to put E in row echelon form, what would I have to do to make it in row echelon form? It's almost there. I just have to tweak it one little bit. Yes, I have to fix this 2 to make it a 1. And to do that, I would divide everything by 2. Does that make sense? Then that would be in row echelon form. Okay? Now, truth be told, I'm going to be honest with you. If I were just solving this and it didn't give me specific instructions to put in row echelon form, could I do back substitution with the way it's written right here? Yeah, I could. So depending on the directions, what the directions say, if it doesn't ask for row echelon form, by all means, go ahead and start back substituting at this point. But it's not technically in row echelon form. Good? Okay. If I gave you one that was a little bit longer, could we do it? Well, before we do that, yeah, let's do it. Let's do it. Let's do it. Here we go. So what's the first thing I'm going to do, Aiden? Well, you got to know what I call it. What do I call it? What kind of matrix? Yeah, you got to make it into an augmented matrix. So, John, would you like to do that for us?
I would get, for the first row, I would get 2, negative 1, 0, and the answer would be 7.
Yep. So I keep on going, you will pass the buck. Okay.
So 1, negative 1, 3, and the answer is negative 4. 1, negative 4, 3, negative 2, and the answer is 18. And 0, 1, 1, and negative 1, and the answer is 1.
Yep. So when I start this problem, I want to have row 1, column 1. I want it to be a 1. Do I have a 1 there right now? No. I could by doing what, Kyle? Yeah, so I'm going to take the time to switch row 1 and row 2 before I do anything else. I could have switched 1 and 2, or I could have switched 1 and 3. It doesn't matter. You're going to have different work along the way, but you should get the same answers. So we said we're going to switch row 1, and so we're going to take these 2 rows and switch them. If you have a 1 here, then what I try to do is I try to use row 1 to put a 0 in row 2. Try to use row 1 to put a 0 in row 3. Use row 1 to put a 0 in row 4, but I don't have to do that this time because there's already 0 there. Does that make sense? So if I'm using row 1 every single time, and I don't have to, but I just think it's easier. If I use row 1, what do I have to do to row 1 so that when I add to row 2, it's a 0? Okay? Multiplied by -2. And you see how I'm showing my work over to the side? That's a really good practice, don't you think? Whoopsie, I wrote that wrong though. Only if I write it right. Now when I look at this, I know that I'm going to want to put this in for my new row 2, yes? What could I do that would help me so that, because eventually I want this, what I want is in my row 2, is I want it to be, like, I want it to be 0 and then I want it to be a 1, right? That's what I want. Is there a way that's easy to make that so it's the form that I want? Zoe? Yeah, and the only time I would actually do that is if everything were divisible. Does that make sense? So if everything's divisible by -3, I'm going to go ahead and divide that by -3. And I'm going to have 1, -1, 2, -5. And here, if we're keeping track. I guess I can do that as we go. Row 1's not going to change. There's row 2, then my new row 2 that I found. Now I want, for new row 3, I want this to be a 0. Kevin, what are you going to do? I wonder. Can I divide that one by anything? Yeah, don't introduce fractions unless you have to, but in row 3, or the last fourth row, I just copied down because I already had that 0. Right now, column 1 is good. I have a 1 with all zeros underneath it. If I'm putting in row echelon form, and I'm not doing reduced row echelon form, I'm done using row 1 to do any fixing. Because if I use row 1, that's going to, because of that 1 that's in the first row, first column, that's going to put a different number here, and I don't want to do that. Make sense? Okay, now I'm going to fix now I'm going to work on row 2, or column 2. I have this 1 here, which is what I want. I just now need to make these 2 zeros. So if I'm going to make this -5 a 0, what should I do? Vincent? I could. Is there something else I could do? I'm going to do that, but is there something else I could do? Yeah, I could have also done it by row 2. But you want to do row 4, so we'll do 5 times row 4 plus row 3. Oh, that's really messy. Now I did that to get rid of that negative 5, so I'm going to put that in row 3. Can't divide by anything, so I'm not going to try. Does that make sense? I don't have a common factor. Now I need to make this 1 a 0. How am I going to make this 1 a 0? Jasmine? Okay. So cannot divide by anything, so I'm just going to copy it down. Kyle?
There was a mistake made because it was 0, 9, 10, and 7. Because if you see your equation multiplied by a 5, not a negative 5, so it should be 0, 5, negative 5, plus 10, minus 25. It should be a negative 1 there, shouldn't it? Instead of a 9, because it should be a negative 5 plus 4.
I multiplied row 4, this one, by 5. So that's 5, 5, negative 5, 5. 5, 5, negative 5, 5. And then row 3, negative 5, 4, negative 5, 22.
Oh, that's my fault.
Yeah, I did drop the negative sign though. So I did do that. I caught that. Okay, so checking. 1, 0's below. Have this 1, 0's below. Yes? I need to make one of these to a 1. Which one's going to be easier to make a 1? Probably this one's going to be easier to make a 1. And I'm just going to divide that by, what would I divide this by to make it a 1? 2. So I'm going to divide all these by 2. Yes? And I hate to do this, but I'm going to write it down again. I just like writing it down. It makes me feel better. These are not short problems. So I'm moving this up to here while I do that. Are you good with that? I'm going to pretend like you're saying yes. So I have this 1 here. What do I want to make this? I want to make it a 0. How will I make that a 0? What I have, I can think of it this way. I used row 1 to fix column 1. I used row 2 to fix column 2. I should have, but I didn't really. In order to fix column 3, chances are I'm going to use row 3, right? I can't go back up to row 2 because that'll mess up these zeros. Can't go back up to 1 because it'll mess up all these zeros. So I'm going to have to use row 3. What can I multiply row 3 by that when I add it to row 4, that 9 will go away? Negative 9. Oh, that's positive 27 over 2, yes? So I want this technically to be 0, 0, 0, and I want this to be a 1. What do I have to divide by? 7 over 2. It doesn't really matter because it's still going to be 0, right? 0. So now that is my last piece. Because now I'm in row echelon form. I have my main diagonals of zeros. When I think of this as not being there, everything below that is zeros. So now that I hit this point, what could I do? Once you hit that point, Ryan, what can you do? Yeah, you can put them back into the equations to do back substitution. Oh my, look at that. That's not what I wanted. I'll give you a second. Aiden, do you have answers for me? Pardon me, what? C equals... Anyone have the last one? Hmm? I get x is equal to... Oh, that's a 5, isn't it? X is equal to 1. So 1, negative 2, 3, 0. That's not bad, right? Huh? Well, just imagine how fast you'll get. Okay. All right. Okay, the last one says Gosh Jordan elimination, which means you're not going to do the back substitution. You're going to put it in reduced row echelon form. Which means, see here when I stopped, when I got all those zeros. Oopsie, right here. I got all those zeros. Now for this one, what we're going to have to do is we're going to have to go through the process of making all these appear zeros as well. How? He says. Oh, would you like some blank paper then? Do you have notebook paper? You want me to give you paper? Thanks, Mrs. Ward, for printing out the notes for me. All right, let's go. You might want a separate sheet of paper. I don't think I gave you very much room. All right, so I'm going to do the augmented matrix first. Connor, what's the augmented matrix? I wrote -3, -5. Dropping one negative sign can kill you in these problems. All right, next row, Vincent, quickly. -4. And the last row, Jasmine. -2. So I should be happy because I have this 1 here, yes? So I am happy. All right, Scott, how am I going to get rid of that 3?
You multiply the first row by
So I'm going to do -3, 0, +9, +15, 3, 1, -2. Bonus. Why do I say bonus? Because I planned to get the 0, but I got a 1 in the deal too. That makes me very happy. Okay, now I want to make this a 0. What am I going to do to make that a 0, John?
You would multiply row 1 by -2 and add it to row 3.
So -2, 0, +6, +10. So after I fix column 1, the first part of column 1, everyone's good with that matrix that I have right there, yes? Okay, column 1, I have a 1 followed by 2 zeros, good. Now I had a 1 in row 1, column 2. No, row 2, column 2. So now I'm going to use that to make this 2 a 0. How am I going to do that, Andrew? Which I have multiplied row 2 by to make this 2 a 0. Andrew? -2 times row 2 plus row 3. When I get that 0, 0, -7, -14, what should I do to make my life easier, Ryan? Divide everything by -7. I'm going to get 0, 0, 1, 2. So at this point, this is where we stopped last time, but we're going to go on. I'm in row echelon form now. Oopsie, that's a 0. And I could do back substitution, but we're going to do reduced row echelon. To do reduced row echelon, I have these zeros. Now I need to work on making these zeros. Yes?
So would you do -7 times row 3 plus row 2?
-7 times row what?
Row 3.
Yes. Yes. And I don't have to do anything. This 0 is already here, so I don't have to do anything for that. That was a bonus too. So what he just said was he said whoopsie. -7 times row 3 plus row 2. Because I'm fixing column 3. Huh, that's what that was up here. So when I do that, I'm going to 0, 1, 0, -3. Row 2, or row 3 is already good. I now need to make this -3 a 0. How am I going to make that -3 a 0, Kevin? This -3, huh? See how that -3 is in column 3? I'm going to use row 3. So what do I have to do? Multiply it by 3. So I'm going to take 3 times row 3 and add it to row 1. So 0, 0, 3. Whoopsie, that's a funky 3. And then row 1. 1, 0, -3. 5. So if I'm in reduced row echelon, I know that x is equal to 1, y is equal to -3, z is equal to 2. That wasn't bad. That was not bad. Yes?